Good day everyone, this is Danica Nicole Agora Banyal, and at this point I'm going to tackle about the structure-function connection of proteins. Proteins are polymeric substances composed of many amino acids linked together in a unique sequence. Proteins are a major class of food needed for growth and maintenance. Proteins has many different functions including serving as structural materials and as enzymes. Proteins also classified as simple or as conjugated. Simple proteins yield only amino acids when hydrolyzed, whereas conjugated proteins yield amino acids plus at least one additional product. The function of a protein is determined by the unique sequence of amino acids units in a protein and its structural organization. The nature of amino acids. An amino acid is any molecule with at least one carboxyl group and one amino group. The amino acids found in proteins are called alpha amino acid because the amino group is attached to the first or alpha carbon atom adjacent to the carboxyl group. This is the general formula of alpha amino acid is shown below. The variable R group, the carboxyl group, and the amino group are attached to the alpha carbon atom. The variable R group, commonly referred to as the side chain, can contain alkyl groups, aromatic groups, NH2, carboxyl group, OH, and S-containing groups. Amino acids are divided into 4 groups based on the characteristic of the amino acid side chains as seen on the following slide. This classification has been chosen to emphasize the importance of the side chains in amino acid and protein structure. Number 1, the nonpolar amino acids. The side chains are either aliphatic or aromatic and are hydrophobic. Number 2, the polar uncharged amino acids. The side chains contain functional groups with polar bonds such as alcohol or amides and are hydrophilic. Number 3, the acidic amino acids. The side chain contain a carboxyl group, also called as negatively charged amino acids due to their form of physiological pH. And lastly, the basic amino acid. The side chain contains a nitrogen that can act as a base, also called as positively charged amino acids due to their form of physiological pH. Amino acids are classified as basic, neutral, or acidic depending on whether the ratio of NH2 to COOH groups in the molecule is greater than 1 to 1, equal to 1 to 1, or less than 1 to 1 respectively. This ratio differs from 1 to 1 only if the amino acid side chain R contains an additional amino or carboxyl group. On the following slides, shown the classification, names, abbreviations, and structure of the common amino acids derived from proteins. So this is the nonpolar, its names, its abbreviation, and its formula. Second one was the polar uncharged. The third was the acidic, and the fourth was the basic. This is the structure of an alpha amino acid that has a methyl group as a side chain. So, as you see at the letter B, that is the glycine, and the letter C, that is the alanine. The alpha carbon atom of the alanine molecule is bound to a methyl group, making it one of the simplest alpha amino acids, and also results in alanine's classification as an aliphatic amino acid. The methyl group of alanine is non-reactive and is thus almost never directly involved in protein function. So, what is the classification of the amino acids shown below? So, this amino acid is polar uncharged because it contains a polar hydroxyl group. What about the following is not attached to a alpha carbon of amino acid that is used to make protein molecules? So which one of that? Which one of this. A group containing a phosphorus atom. So this is a group containing a phosphorus atom is not attached to an alpha carbon of amino acid that is used to make protein and molecules. Amino acids that are in proteins contain all the groups listed except for a group containing a phosphorus atom.